Okay, hello and welcome to the first video of Algebra 1. So this is how all of the chapters will start, and we have about 4 lessons in Chapter 1. So we're going to start with Lesson 1.1, Solving Simple Equations, in your note packet. The next slide and space in your note packet is just the workspace. You could use that for warm-ups. So right now we're going to leave it blank. And then we're going to see some key ideas. These will be kind of features of each video. So the key ideas kind of give you the main idea of what the lesson is about. And it also is a place that provides some definitions for us. We have the addition property of equality. That means that adding the same number to each side of an equation produces an equivalent equation. And the subtraction property of equality, where subtracting the same number produces an equivalent equation. These two, addition and subtraction, are inverse operations. One will undo the other. Same is true for multiplication and division. They are also inverse operations. So when you multiply each side of an equation by the same number, you get an equivalent equation. And when you divide each side by the same number, you produce an equivalent equation. This is an example from your textbook. No need to write anything down unless you feel like you want to. I will highlight a few things here for you. Okay, in this first one, x minus 7 is equal to negative 6. So we are undoing this subtraction. So we will be adding 7. That's the additive inverse. Notice that this negative 7 and positive 7 will undo each other and make a zero pair. Sometimes I like to cross that out. Then we take negative 6 plus 7, which is 1. If x is equal to 1, you could substitute that 1 in place of the x. 1 minus 7. Does that equal negative 6? This is a mental math check. You can write down that work. You will always know you're getting it right if you do the time to check your work. For this one, we're undoing multiplication. However, we're multiplying by a fraction. So to use an inverse operation would be division. When you divide fractions, you are multiplying by the reciprocal. And if you need more explanation on that, drop a question, something maybe in the last place on Edpuzzle, because I can review that with you in class if you need to and do further explanation. But we're going to multiply by a negative 4/3. That way, the 4's cancel, the negative 3's can cancel, you'll get n by itself. Negative 4 times negative 2 is a positive 8 over 3. So we have 8/3 there for our solution. And again, you'll want to check your work. Okay, so we are not going to do all of these. I'm just going to kind of, 1, you're going to undo addition, 2, you'll undo subtraction. So let's jump ahead to 3. The reason I'm choosing 3 is because the variable is on the right. So we always want to start on the side of the equation where the variable is, k plus 3. That's what we're undoing, this addition. So we're going to subtract 3 from both sides, okay? All right, so if we subtract 3, 3 minus 3 is 0. Always make sure that that's a 0 pair, that when you cross it out, it actually is 0. So we're bringing down the k. That's going to be equal to negative 3 plus negative 3, which is negative 6. So here's where we want to put in that negative 6. Is negative 6 plus 3 equal to negative 3? Notice I kind of switched around the equation, but I kept the terms that were together on the same side. But negative 6 plus 3 is in fact negative 3. Negative 6 plus 3 is negative 3, so we know that it checks out. Moving on to number 4. In this case, we want to undo. Notice I'm drawing that line to kind of keep where the two sides of the equation are. It kind of helps see things very clearly. We're undoing subtraction, so we're going to add pi. Pi is not a variable. It is an irrational number. So negative pi plus pi is a 0 pair. It crosses out. So r is equal to 1, 2 pi. So we can count them. Okay, so now if we have, in place of r, 2 pi minus pi, well, if you have 2 of something and you minus 1, you're going to get 1. So we know that that checks out and that r is actually equal to 2 pi. Okay, these two are pretty self-explanatory. Let's jump down to 7. Let's undo division. We'll undo division with multiplication. So we will multiply both sides by a positive 4. That means the 4's cancel out. Y is equal to negative 7 times 4, or negative 28. Again, I can check my work. negative 28 divided by 4. Again, that's going to be equal to negative 7, and I know that it works. Last one I'll do on this page for you is right here. There's the equal sign, so I can draw my line. I'm looking for the variable. The variable is x. What's happening to x? It's being multiplied by pi. So I can undo this multiplication with division. So let's divide both sides by pi. Pi's cancel. 6 is equal to x. It's kind of like an identity. 6 pi is equal to pi 6 or 6 pi. So we know that that checks out as well. Okay, this is a little video example from your book, and I think we're going to do this in class together. I was having a little technical issues of having this actually record on the video that I'm recording, so we're going to do this in class tomorrow. Moving right along, so flip the page of your notes, and you'll see example 10. Now, before we start to do example 10, let me find my little pointer here and get my pen. Here's the equal sign. Notice that there are some things we need to simplify first. These two, right? Because p minus 8 divided by, so half. We're going to do order of operations. We always have to do the division before the subtraction. Well, 8 divided by half, right? 8 divided by, oh, and look what I did. Let me just clear the screen because I don't know where the, interesting. That's so weird. Okay. I meant to do 8. I meant to do just the divided by sign, and I ended up doing a fraction. By half is going to be the same as 8 times the reciprocal of a half, or 8 times 2, right? How many halves are in 8? Well, there's 2 halves in 1, so that makes sense that there would be 16 halves in 8. So 8 divided by half is 16. Okay, when you're dividing by a fraction, the number actually gets bigger instead of smaller. All right, so now we're doing p minus 16 is equal to negative 3. So I will add 16 to both sides. And I will get p is equal to, so now we have positive and negative, so we'll subtract them, which is 13, and it's a positive 13. And then you could check your work because it would be 13 minus 16 is negative 3, and we know that we did it correct. On number 11, you have to remember these absolute value symbols mean the distance from 0. So how far away is negative 10 from 0 on a number line? It is 10 spaces. So q plus 10, writing it without the absolute value symbols. So now we're going to subtract 10 from both sides. And we'll get q is equal to negative 8. So negative 8 plus 10 is a positive 2. We know that that checks out. Okay. Let's see. I'm going to see if I can move this. Yes, hello. Okay, so that we can work on this one. The melting point of Mercury is about 1/4 of the melting point of Krypton. The melting point of Mercury is this negative 39 degrees Celsius, and that's pretty much the first thing right here. The melting point of Mercury is equal. So I know that I can do negative 39 is equal to 1/4 of Krypton. 1/4 of whatever I want it to be, but I'll call it K for Krypton. Okay, so this is my equation to write and solve my equation. 1/4 of Krypton would be equal to the melting point of Mercury, and that is negative 39. So I'm multiplying both sides by the reciprocal of 1/4, which is 4 over 1, right? That's going to cancel these 4s. So take this times 4. 4 times a negative 39, you can do it in your calculator. You'll get that K, or the melting point of Krypton, is going to be a negative 156 degrees Celsius. All right. Great. And for this, now we're going to go back down. Oh my, I don't know what I just did. I'm blue. Don't know why I'm blue. I don't know what I did. Oh my. Oh my. I'm going to pause for 1 second. Okay. Sorry about that. Turned myself blue. Kept clicking through all the slides. That was just, okay. A little out of practice on the recording, maybe. All right. So I want to stop right here. This is our last slide of lesson 1.1. I'm going to explain what you're going to do, and then you'll see on Edpuzzle. So we'll end every lesson with this vocabulary and concept check, or at least, yes. And so today there's 3 questions. You will be picking one, 2, or 3. You do not need to answer all 3. You will be prompted in Edpuzzle to answer one of these questions. Okay? So you will be typing in your answer, thinking about it, typing it in. But it will say, so I want you to, when you type it in, I want you to type in, like if you're choosing one, put a number 1 and then type your answer. That way, when I'm grading it, everybody could be doing a different one. I need to know which one I'm grading, right? Am I grading the answer to 1, to 2, to 3? So that's all you need to do. You don't have to retype the question for me. But the prompt will be something like, please let me know which number you decided to answer for the vocabulary and concept check and give me your answer. All right? Then you will be prompted to answer. The final slide would say, are you left with any questions? If you had any questions from taking notes, if anything came up while we were doing the examples that you didn't understand, that's going to be the place where you can put it. If there's none, you can say none or no thank you or whatever you want to say. Okay? Thank you very much. You've been a wonderful audience. And until the next video, that is all.